Hello guys, welcome to our second last part of type of reaction, which is replacement. So we are going to talk about replacement reaction. This is a general knowledge to help you predict chemical reaction. So replacement, we have the first one, we have single replacement reaction. Single replacement reaction is a reaction in which atoms of one element replace atoms of another element from a compound. So what is a single replacement reaction? It's a reaction in which atoms of one element replace atoms of another element from a compound. So that is a single replacement reaction. For example, when sodium metal is placed in water, there is we see many observations, four observations. A fizzing sound is heard because of production of hydrogen gas. It floats in water because it's less dense than water. It darts on the surface of water because it's propelled by hydrogen produced underneath. So sodium metal and a solid plus water, H2O liquid, sodium is going to displace hydrogen gas from water, which is a compound. It's going to displace hydrogen gas from water, which is a compound. Therefore, it's going to form sodium hydroxide. Sodium hydroxide aqueous, a base, plus hydrogen gas. So it has displaced hydrogen from a compound, which is sodium, which is water. Compound, which is water, it has displaced hydrogen to form sodium hydroxide. Balancing the equation, hydrogen is 3 over there. So what can I do to balance this equation? Let me put a 2 here. Hydrogen to be 4. 2 plus 4 plus 2 is 4. So I put a 2 here again. Hydrogen becomes 4. Oxygen is 2. And here is 2. And the equation is balanced. So sodium displaces hydrogen atoms from water to form sodium hydroxide and hydrogen gas. That's why we have effervescence or a fizzing sound due to production of hydrogen gas. We'll talk about displacement. We are in replacement, but we have a displacement reaction. What is a displacement reaction? Here. Displacement reaction is a reaction in which more. So we'll talk about displacement under this. After that, we'll talk about displacement. Now, it's a replacement reaction, but we commonly refer to as displacement. Displacement is a reaction in which more reactive elements, displace less reactive elements from the solution of its ions. So displacement is a reaction in which more reactive elements displace less reactive elements from a solution of its ions. So that is a displacement reaction. In this, you must know the reactivity series. The reactivity series is O, So, Pa, Ma, alzine hydromesigo. Poso kama alzine hydromesigo. Poso kama alzine hydromesigo. Po is potassium, so is sodium. Ka is calcium, magnesium. Aluminium. C, carbon. Zinc, iron, lead, hydrogen, copper, mercury, silver, gold. This is very important reactivity series that you know. Potassium is the most reactive and gold is the least reactive. Poso kama alzine hydromesigo. Potassium, sodium, calcium, magnesium, aluminium, carbon, zinc, iron, lead, hydrogen, copper, mercury, silver, gold. This is the reactivity series. It's very important. Poso kama alzine hydromesigo. Poso kama alzine hydromesigo. Potassium, sodium, calcium, magnesium, aluminium, carbon, zinc, iron, lead, hydrogen, copper, mercury, silver, gold. So this is the reactivity series. And for example, we have a solution of copper sulfate. Now, displacement reactant. Copper sulfate, aqueous. Copper sulfate is a solution that is color blue. Copper sulfate is a solution that is color blue. You can see copper in the reactivity series. When you react it with iron, look at iron in the reactivity series. It means iron is more reactive than copper. Iron is more reactive than copper. Therefore, when you react it with iron, which is gray, poso kama alzine hydromesigo. Potassium, sodium, calcium, magnesium, aluminium, carbon, zinc, iron, lead, hydrogen, copper, mercury, silver, gold. Iron is above copper in the reactivity series. Iron is above copper in the reactivity series. Iron is above copper in the reactivity series. Therefore, if you add iron in copper sulfate solution, iron is going to displace copper from its solution because it's more reactive. Therefore, copper is going to be displaced from its solution because it's less reactive. So iron will take the solution. So iron will go into the solution. So it forms iron sulfate aqueous plus copper solid. So these are displacement reaction. More reactive elements displace less reactive elements from a solution of its iron. So when I balance this equation, because they are in balance to all of them, the equation is balanced. This solution is color green, and the solid that is formed is color brown. So iron is more reactive than copper in the reactivity series. Therefore, it displaces copper from its solution. So the ionic equation here is copper ions aqueous plus iron solid is going to give us fair in solution, iron to ions aqueous plus copper metal. So that is a displacement reaction. Another type of, another example, let me see, for example, we have zinc sulfate and magnesium. So zinc sulfate aqueous. Zinc is below magnesium in the reactivity series. Zinc is below magnesium in the reactivity series. Therefore, if I react zinc sulfate with magnesium solid, magnesium is going to displace zinc from its solution. So it will form magnesium sulfate, aqueous, plus zinc. So zinc is going to displace from its solution because it's below magnesium in the reactivity series. This is very important in your chemistry life. You should know this chemical equation. So the ionic equation is zinc ions aqueous 2 plus magnesium solid. It gives us magnesium ions in aqueous state in solution because it has been displaced from magnesium. It has gone in solution because it's more reactive, plus zinc metal. So zinc metal is displaced from its solution. So this is the ionic equation that occurs. So a displacement reaction is a reaction in which more reactive elements in the upper cadre displace less reactive elements in the lower cadre from the solution of its ions. So in our next class, we look at double replacement reaction where we exchange ions, also known as precipitation. Thank you. In our next class, we look at double replacement reaction, which is precipitation. Thank you.